on it too. I felt like this lesson was so much easier though. I'm like, whew, refreshing. Of course, we'll see when we get to the quiz. Are you guys ready for the exam?
No.
Yeah, me neither.
A lot of studying. When does it open?
It might already be opened. I know it's due Saturday this time, which is super nice for me because Wednesdays are nuts.
Oh, it's due this coming
Especially with how long it took me for the last exam.
What's that?
It took me so long with the last exam that I'm definitely taking it on Saturday.
Yeah, I'm glad that the due date is later because the due date was Wednesday and that was just so hard.
Yeah.
That's all right. All right. Okay. Do you guys have it open?
Uh-huh.
Okay. Okay. So
all right. So
soccer shoes and hot dogs. Let's see. Hot dogs. Soccer shoes. Applet. All right. Love it when you can just click on it. Like it gives you the spreadsheet right away. You don't have to go searching for it.
That is really nice.
It is.
Bless Sister Wilkinson.
Would you say bless her?
Yeah.
I know. She's amazing. Okay, so in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate that at least one mean is different from the other.
I say true.
I think it's true.
That's what I would go with as well. Yes, that would be true. Okay, what requirements need to be checked when performing an ANOVA hypothesis test? So you're just performing the test, so you don't have to know that they're all positive. Sample means they're all positive. Data in each group are normally distributed.
I think the last two.
Distributed.
What's that?
I say the last two.
The last two?
Because in the lesson, it says the data are normally distributed in each group as a requirement. And then under that, so there's two requirements. The data are normally distributed, and then the variances are equal for each group.
Okay.
Yep. Okay.
Okay. Yep. All right. The last two. Check if each group is normally distributed. To check, do the following.
Isn't it UQ plot?
Yeah. UQ plots. I like how it says scatter plot. We've never used that word. I love it when we have words used. I'm like, yes. Okay. We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller than the sample mean. That's new. The largest variance is less than 4 times the smallest. No, it would be backwards. The largest sample mean, wait, hold on, is less than 3 times the smallest sample mean. Hold on, I gotta go to my notes.
I'm pretty sure it's less than 4 times.
Yeah, it says if the largest variance is not 4 times the smallest, is that right? Then we conclude that variances are equal. It's less than 2 times, less than, oh yeah, so the second one, right?
Yeah.
Mm-hmm.
That's what I put.
Yeah, I think it says it in the lesson.
Okay. I think I wrote it wrong in my notes. I need to change that. not 4 times the smallest. I think I wrote it right. Okay. And ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. Well, how many pairs are there when there are 4 samples? 1 to 2, 1 to 3, 2 to 3. Hold on.
Wouldn't it be 4? No.
Well, is it 3?
Because if it's independent 2-sample t-test between every pair of samples. Okay, I have to.
I would say 4, but is it one of those trick questions?
Maybe.
That's what I was thinking, is it was 4, but seems too easy.
Yeah.
Because if it's a sample test with the pair of samples, does that mean that for every sample there are 2 pairs?
I know, that's what I was wondering.
Yeah. So if there are 3 samples and they each have 2, then it's 3 pairs. So adding 1 more would mean 2 more. So it'd be another pair. Does that make sense?
But
where do I find this?
I don't get the whole 1, 2, 1, 3, 2, 3. Okay, but in the homework or in the book, it says one possible method. It's asking you to analyze the data. It says one possible method would be to conduct separate t-tests for all possible pairs of the group in the study. So if we did this, we would need to conduct a separate t-test to compare the groups. So you would be comparing 1 against 2, 1 against 3. Then you would have to compare 1 against 4, 2 against 3, and 2 against 4. Hold on. Oh my goodness. Because you're comparing each of them to each of them. Oh.
This one's tricky.
1. Yeah, no. So you're comparing 1 to 2 because you're comparing those 2 together. Then you have to compare 1 to your third. Then you have to compare your second to your third.
They each need to be compared with. I know what you're trying to say. I don't know how to explain it, but I get it.
I don't either. But yeah, I get that they're like trying to compare each to the other one.
So if we have 4 samples, we would have to do a 1 to 2, a 1 to 3,
1 to 2, 1 to 3,
a 1 and 4, and then a 2 and 3, and then a 2 and 4, and a 3 and 4. 1, 2, 3, 4, 5. So I got 6. I don't know. So 1 and 2, 1 and 3, 1 and 4, 2, 3, 2, 4, 3 and 4. That's everything, right? I think that's everything.
Yeah, I think you're right.
Yeah.
6.
Yeah, that covers it all.
Okay.
Don't get it wrong. Got another try. The data in soccer shoes is collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, and A, B, C, D, E, and also just wearing socks for a total of 6 groups. Okay. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Oh,
So do we plug this into the quantitative inference?
I think you put it in NOVA because you have 5 types, right?
Right.
Yeah.
So we go into the quantitative inference procedures and then click ANOVA.
Right.
Oh,
Okay.
yes. Sorry.
It says that I have, no, you're fine. It says that I have 6 variables on the ANOVA.
Yeah.
Is that right? Okay.
Yeah, you're going into
I'll do this
ANOVA, and then you're going to copy and paste all that data. So
Wait, so I only have so where if I have 6 columns, where do I put everything? Because the only one with numbers is column B in the soccer Excel sheet. Does that make sense?
Oh, so if you look in column A, you'll see that it says A, and then in 22 it starts B. So you copy all the A's and then B's and then so on.
Oh, thank you. Sorry, I'm
Oh, you're fine.
slower. Yay. So, Elise, on your bus route this morning, did you get any kids dressed in their Halloween costumes?
No, I didn't.
they're not allowed to.
Really?
Yeah, they're not. The only reason why my kids got to wear their costumes was because it's a charter school. And the principal's like, no, we're going to have holidays. And I'm like, you rock. Like, that's how it should be.
Why aren't they allowed to wear it?
Hanukkah. Let's learn about Day of the Dead. Like, let's make it educational, you know? I don't know.
Oh, yeah.
I'm all for it, but I know.
I am too.
It's like the one kid that doesn't celebrate holidays, and you feel bad for him. Like, everybody celebrates everywhere, you know? I don't know.
But that's why they're not allowed to wear it, just because for the ones who
And I feel bad saying it, but yeah, it's because of the one kid. And
oh, that is kind of sad, though.
Yeah, it's sad for them, but I'm just kind of like, I don't know. I don't know how.
Kid, yeah.
Like, I get it. But.
No, me too. But it's like, you know, so like when I was in school, we did like the DARE program, you know, like against drugs. And I had a friend who didn't participate, but she would just get it, you know, like during the program and stuff, she would just get to go to like the library and read or something, you know, so it wasn't bad or anything.
Yeah.
You know, so I'm like, oh, I don't know. I don't know why they couldn't just.
Yeah. I mean, it's like, I think if there's an opt out, you know.
Yay. That's so many kids that don't get to dress up.
What's that?
That's so many kids that don't get to dress up, and they probably want to.
Preschoolers still do it, I think.
Yeah, preschoolers, because it's not yet public, you know.
Well, I mean, like special ed preschool.
Oh, okay.
They do like a parade every year. Everyone brings their costumes and then walk around campus.
I bet they're just adorable.
They're so cute.
Love it.
Okay, do you guys have it copied? It took me like 10 years.
I have one more. I'm slow.
No, please.
Okay. How many classes are you guys taking again?
I'm just taking this one.
Okay.
Oh, good. I'm
smart.
I'm taking four classes.
Same here.
I'm only taking 12 credits, but I'm really struggling this semester.
This semester's been hard. Annie, do you have kids? I don't remember.
I don't.
Okay.
That helps. But
yeah.
Yeah. Not that I don't like kids. That sounded bad. I absolutely love kids. I want kids. Just
yeah.
You know,
but it does make it nice. I love when my kids are in school. Did you get it all done, Elise?
Yeah, I'm good.
Okay. All right. What is the minimum smallest variance for the 6 groups? Round 3 decimal places. So what is the minimum?
Wait, it's between groups or what did it say? Oh, 4, 6.
What is the minimum smallest variance?
The variable 3.
Yeah, variance.
Or variable 4? Oh, no. What am I thinking? Variable 3. Yeah.
Yeah, 3. Variable 3. So 27.208.
That's what I got.
Okay.
Sweet.
Done. Okay. What is the maximum largest variance for the 6 groups?
Would it be the 53?
Yeah,
Yeah.
that would be 4.
53.158.
Yep.
Satisfied.
Is it satisfied?
Okay, I am confused.
The variance doesn't, the answer in question 8 doesn't, if it's 4 times larger, doesn't that make it not equal or something?
Let's see.
If the large.
Okay, if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Okay, say that again at least.
Let's see. If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Okay, so the largest needs to be 4 times the smallest?
Which isn't the case here.
No. So then it's false? For number 10 then?
No.
Or it could be true.
But that says equal, not satisfied. So I don't know if there's a difference.
So the test for the equal variances is satisfied.
Well, would we be rejecting the null? It doesn't even have.
Well,
it doesn't state the null, right? Or not the null, the variance. What is that called? I don't know.
Do they have the standard or the level of significance? Did they give that to us?
I don't see it.
Yeah, I don't see it on here.
Now I don't know if we're supposed to reject or not.
Yeah, I think we reject it if. Oh my goodness.
I don't know if that's what it's really asking, if we reject it or not.
Yeah. Shoot.
Do we need to check the QQ plots?
That's number 11, actually.
Oh yeah, that's the one I was looking at. Oops. Okay. Sorry, I got off. Okay. The test for equal variance is satisfied for these data. I'm
going to say false.
Since the largest variance is not 4 times larger than the smallest variance, we can assume the variances are equal.
There are 2 requirements of ANOVA that must be checked. The data are normally distributed in each group, and the variances are equal to each group.
And it doesn't say normal in the information. So then you said the variance have to be equal?
For each group.
Equal?
Largest is less than or equal
And
to.
they're not equal.
Yeah,
So
I'm going to say false. I think it's false. Because it's not equal or 4 times as the minimum.
Right.
okay.
I think that the fact that the requirements aren't met makes it not satisfied, but
Mm-hmm. Yeah, I'm going to say false.
Okay. Yeah, I agree.
How do we make a QQ plot?
So you're going to be copying and pasting all that information into the, let's see, where's that file?
The quantitative descriptive statistics, right?
Yeah, that one.
It will open. Okay, and so do I just copy all 6 columns of numbers and just put them into the A?
Wait, didn't she say there's a way to make a QQ plot without going into that other spreadsheet? It was like you select them all and then you go to make a plot. I don't know. No, that was for the
Is that a histogram?
whisker, the
Oh, the box and whisker plot
I
thing.
think that's what it was that she was doing. Okay, so yeah, you're gonna have to input each of those rows.
So I only have on the quantitative descriptive statistics to paste in numbers, I only have an A column. So
yeah, you have to make one plot and then you have to make another plot. Like you have to make a plot for all of them.
So in A, I'll put like the variable 1 numbers, and then I'll make another for variable 2. Does that make sense here? Maybe I can share my screen. Is it working?
The test question.
Is this working?
Each of the samples are approximately normal based on what you say. Okay.
Let's see.
Okay, so the first one is normal. Let me see what your screen looks like. Are you sharing it?
Okay. Is that working?
Yeah, so you're gonna, wait, no, go to QQ plots down at the bottom. You see at the bottom where it's histogram and descriptive stats. Yeah, go to QQ plots and then copy and paste your information in that left box.
Over here?
Yeah, in column A.
So do I do all the variables? So do I do variables?
Just variable 1.
1 through 6?
Just
variable 1.
Yeah.
And this one.
Yes.
Okay. Cool. Now I have to figure out how to stop sharing.
I wish Megan would jump on.
I know.
Okay, how do I stop sharing my screen? Ah. Oh, right here. Okay.
What?
I just got the text. Jump on, Megan.
I miss her.
I know.
It's not the same without her. Okay, so did you understand how to do that? Sorry,
Yeah.
Annie, you're not showing your screen anymore. Did you sort and filter smallest to largest?
Okay.
Okay.
So does this look right?
Yes, but you're gonna highlight all those cells again.
These ones?
Yep, and then you're gonna go over on the right-hand side up at the top. Do you see that A with the Z underneath it? Sort and filter, go smallest to largest.
Oh,
there
cool.
you go. So the first set is gonna be normal. So we have to test every single set.
So I just
that makes sense.
Putting like now I do variable 2 in the box.
Yeah, now you're gonna do variable 2.
Okay. Thanks, guys.
No problem.
It feels so powerful when I understand Excel stuff.
Right.
Wait, so how do you sort it again?
How do you what?
How do you sort?
So on the right-hand side, you're gonna see like an A and a Z. Let's see, hold on. and it says sort and filter. It looks like I don't know, like a funnel.
Hmm.
It looks like this shape. If you want to share your screen,
I don't have it.
you have to go
Maybe
to.
mine.
You can share your screen if you want. You know, at the top where it says like insert, page layout, formulas, data.
You see it right here on my screen, at least right here.
Yeah, so here.
Wait, who's? Okay, Elise, what is going on with yours? Okay. You have home.
Maybe because it's a Mac. I don't know.
I have a Mac too. Let's see.
I figured it out one time, but
okay, so go to the right. Don't go up to tools. Go down.
okay.
Okay. Do you see that little funnel? That A to Z? It's right next to. Do you see the little green function?
Oh, right here?
Yes. Yeah. So go to that. Is that your sort and filter? Go to the A to Z. Go over right there, and go ahead and do like ascending. Try that. Click on ascending. That work? It doesn't say smallest to largest. It should be easy. Try cell value. I don't know.
Oh wait, it did it.
It did it? What did you click on? Or did it just take
I think it just took a little bit.
Okay. All right. So yeah, so yours is normal. So then do the next one. So every time you do it, you're going to have to sort and filter it. What version of Excel do you have?
I don't know. I had it on there at one time, but I don't know why it went to a different spot.
Okay, I just finished my last one. Hooray. Oh, that takes a while.
So were all of yours normal?
I think that mine were fairly normal. My last one was a little bit more than the rest, but they all look normal to me. But
Yeah, all of mine look normal.
okay, so true.
Yes, true.
Yay. Yeah, mine are normal. True.
Yay.
Okay, performing a ANOVA test in Excel. She said to like screenshot this and send it to her because it still says SPS.
All right. And then remove the socks data and perform the test again.
Wait, is it SPS or is it S?
SPSS.
SPSS.
Where do we find that?
You don't. So that just means Excel. It's a error.
Yeah, it's old software that they used to use, I guess.
Yeah.
So we're just taking out, we're erasing the variable 6 column.
Right.
Okay. Sorry, I just emailed her. I just shot her an email. Let's see.
Okay, so I just took out my variable 6 column.
Remove the socks. And then what is the p-value after you remove the socks?
I hope I got that
I got
The socks variable set 5.
0.309, Elise? Is that what you said?
309.
Yes.
Sweet.
Yay! Yeah, I just erased all the data in my variable 6.
Would you say 20 or 0.204?
309.
309. What did I do? You just erased variable 5, right?
6.
Okay.
Oh.
Megan.
I thought there were only 5. I thought there were 5 variables.
There's 6. One is the variable 6 is the socks. So there's A, B, C, D, E, and socks.
C, C, D, E, and socks.
So on like the soccer Excel sheet when you scroll all the way down.
Yeah, I guess I didn't calculate socks. What question would I have missed if I had that in there still?
Maybe 8 and 9.
Mm.
But you got the same answer that we did.
What was it? Oh, yeah. Okay. Gotcha. I just missed the socks. Okay, so then I have 0.309. Is that right?
Yeah, 0.309.
Right. So is the p-value the area to the right or left of the F statistic? So in my notes from watching the videos, they said the p-value for the ANOVA test is the area in the right tail.
Right.
We will never divide the area on the tail. So it would be right, right? Okay. Yay,
Always the area to the right on any ANOVA test?
I think so. P-value for the ANOVA test, yeah.
On the F statistic, the right tail is the p-value.
Always on the right.
Okay.
It's always right skewed.
Ooh, I'm so sleepy.
I hear you.
Let's examine. I wasn't even up that late. I don't even. Well, actually, I kind of was. But.
Okay.
My dog wakes me up early, like every morning. He sleeps in bed with me since my husband and I have been separated. So I wake up every morning. He's like standing over me, like staring at me like a little freak. So it's awesome. Okay, so we make QQ plots and compare them. Construct QQ plots of the calories.
Yeah. So we're testing another file. Let's see.
So then, I see. So we make QQ plots for calories of beef, then one for meat and one for poultry, right?
Yeah.
Sweet. Excel is not framed. And small to large. Okay.
Are we looking to see if they're normal again?
I don't know. I was just going to ask.
Let's examine the calories first. Construct Q plots for the calories of each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
So yeah, if they're normal, then the requirements have been met, right? Or that's part of a requirement or something.
Yeah. Okay. So let's test it. Let's test all of them, just like we did on the other one. Beef, meat. I don't get how beef is different from meat. Just a mixture of meat.
I guess so. I mean, I hear hot dogs are full of everything, so.
It's free meat.
Oops.
So mine have all looked pretty normal. How are your guys' turning out?
All mine look normal.
Okay, good.
I think the second one, beef, kind of looks normal. Let's see, what am I missing? Poultry. Did you guys already do poultry?
Mm-hmm.
Yeah, mine are all following that line. Pretty much.
Mm-hmm.
Okay. Yeah, mine are too. They're not like super crazy.
Oh. So it would be the first one, right?
I think so.
Because all the other ones say that the assumptions have not been met.
Yeah, I think so. The first one. It's trying to confuse you by making there be 3 that are different. Which one is not like the others?
So now that we have to run an ANOVA on it in question 15, and we have 6 variables, but then we only have 3 for the calories, do we just fill in the first 3 and leave the last 3 blank? Does that make any sense to anybody, what I just asked? Mm-hmm.
Sorry, I was reading some of the other answers. Okay, so are you on number 15?
Yeah.
Yeah, so just fill in the first 3.
And then the last 3, just erase them.
Mm-hmm.
Or just blank. Gotcha. I keep thinking it's Wednesday, and then I realize it's only Tuesday, and it makes me super sad.
My hardest days, so I'm like, I don't miss my Wednesday. Although I just got released as Young Women's President, so I'm like super stoked that
Oh my gosh.
he's back.
Oh my gosh, I bet that frees up a lot of time.
It does. It does. Well, we're moving, and I was like, release me sooner than later.
You're like, please. How did your house thing go?
What's that?
How did your stuff with your house end up?
Well, we have a contract. We're just waiting
to close it?
Yeah, we're going to try and talk the price down because the roof needs replaced in the next, it needs repaired, which is like $2,000.
Yeah, they're expensive.
Yeah, well, like the whole roof is $10,000, but we can repair just the part over the garage that like has to be repaired so our garage doesn't sink in. But anyway, the inspection's today, so I'm like really nervous of like, what they might find. Stressful. After today, once I know, I think I'll feel better. I'm pretty sure there's termites, which kind of stinks, but all the houses around here have termites. Like, well, I mean, not around here, but in that area.
We've had termites at our house. We've had to have the tent over our house before.
Oh, really?
Mm-hmm.
Guess if it has to be tented, we're going to have to do it before we move in, I hope. Ooh.
Yeah, it depends on how bad they are and where they're at.
Yeah. I only saw a trail in the garage, so I'm hoping.
Hopefully it's not too bad.
Yeah.
We had a company come over, and it was the coolest thing. They had it was like an x-ray machine for the walls.
Really?
And so they went through and saw like exactly where the termites were at and was able to treat it in the wall.
Wow. Pretty cool. That's pretty cool. Well, maybe they'll have that. Our termite inspection is on tomorrow.
Nice.
Okay, what did you guys get? Sorry for that last answer.
Is your guys' variable 1 longer?
Yeah.
Yes.
Yeah.
Oh, okay. So I was about to freak out. So then my F statistic is supposed to be 16074. Okay, cool. So what is it asking? The degrees of freedom? No. 251.
Conclusion, can you draw?
Okay, so if we reject the null, we have sufficient evidence.
The p-value is 0. So in that case, we always reject.
Wait, if P is high, Q is low, he must go. Yeah, so then we have
0, we always reject it. What's that?
So do we have sufficient evidence then?
Yeah, sufficient. We have sufficient evidence
To claim
all hot dog types have the same mean number of calories. Is that right?
I have to go back up and read the original.
So
You need to put all those numbers in. It's like giving us all those numbers.
So it would be either the first one or the third one, right? Need sufficient evidence. Have all the same number of calories.
Oh,
Where's the mean number?
the mean is different for all of them.
So
Right?
it would be the third one. Then we have sufficient evidence that all 3 hot dog types have a different mean number, right?
Yeah.
So
right?
the null is that they are all equal, and if we reject that, they mean that they are different.
So it would be the third one, right?
Evidence to claim all 3 hot dog types have a different mean number of calories. That's the one that I would put.
Quad.
Which one?
The third one?
There's sufficient evidence to claim that all 3 hot dog types have a different mean number of calories.
Sweet.
Yes.
Oh, good. So now we have to test the sodium. Okay.
So wait, what about 4? We have sufficient evidence to claim that at least one of the hot dog types is a different mean. Oh, they all have different means. Okay. Okay, now let's examine the sodium levels. Consider QQ plots of the sodium level for each of the 3 types. Okay.
Maybe it is the fourth one.
Yeah, let me look at this. Well, don't they all have different means?
Sample size. I think
It could be the fourth one.
Because the means that I have are like 156 point whatever, 158 point, and 118. So they're all different.
They are all different, but I think that this was saying because one of the requirements is that at least one has to be different, remember?
Mm-hmm.
So I think that this is just saying that we have evidence to support that. I don't know. What do you think, Joe?
I don't know. Do you have sufficient evidence to reject the claim? Do they have to have the same mean? Is that one of the requirements?
Let's reject. We rejected because of the p-value.
Yeah, so wouldn't it be, oh, we do not have sufficient, we have insufficient. Yeah, so it's not number 2. We have sufficient evidence that all 3 hot dogs have the same. So, yeah, I think it is number 3.
Okay.
I don't know. I could be totally wrong.
We'll see.
I know.
If we get it wrong, then we'll do number 4.
Sweet. So now we just have to construct QQ plots for the sodium, right?
Yes.
2, 3, 2, 6. Okay, that looks good.
my file go? This is obnoxious. Where did we go? There it is.
That looks good. Oh my gracious. Wait a second. Okay, so it looks pretty good.
Mine all look normal. The last one has a couple that are off, but
Mm-hmm. Yeah, I'm with you, Joe. Or Elise. Sorry.
Sorry,
So
I
then
got it up, but yeah.
So would it have to be the first one? Because that's the only one that says the assumptions have been met. But that seems too easy.
Yeah, my last one does seem like a little weird. Yeah, because they all have to be normal to use ANOVA, right? That's the rule. No, all means are equal. No. Oh.
I'm plugging all these in to the other one to see what the variance is.
Mm-hmm.
So what's the rule about one has to be 4 times?
The largest has to be 4 times
Bigger
The
than the
small,
smallest. Is that right?
less than or equal to 4 times the smallest. Then we will conclude that the variances are equal. So the largest has to be less than or equal to 4 times the smallest. Which is not the case.
Yeah, it's not the case.
So then they haven't been met, right? So it couldn't be the first one. Would it be the second one? Because they all look like they come from a normally distributed population, but we cannot assume that the variances are equal.
Yeah, I think it's the second one.
Because they all looked fairly normal, but the variances are different.
Yeah, I think it's the second.
Sweet.
Okay. Is that what you figured, Elise?
Yeah.
Okay. So now we have to plug in this. Wait. So in the quantitative inference procedures, we have to plug in the sodium instead of the calories. Were we answering the last question based off of calories or sodium?
Sodium.
Crap. I didn't have it in my quantitative. I didn't switch it in my quantitative inferences.
You don't have to do that yet. It was just based off of the Q plots.
Oh. Okay, good. Well, I was looking at the variances. I'm totally like out of whack here, people. Okay, so I tell you paste. I'm gonna just hurry and plug it in and see if it
Now we have to move all our sodium levels over, right?
Yeah.
Yeah, that's what I was wondering, because aren't we answering off of sodium the last question? Yes.
Okay, what'd you guys get?
For the p-value?
Yeah, for p-value. I got 0.80. Is that right? 0.8.
I got something different.
I got 0.179.
Sorry, I'm looking at, yeah, 1.179. Yeah, sorry. Looking at the wrong one, but yeah. 0.179.
That's what I got.
Okay. What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs?
So we fail to reject, so
Yeah.
it's insufficient.
Fail to reject is, yeah, insufficient evidence to reject the claim that all types of it. Is it the second one?
That'd be the second.
I think so. Wait,
yes.
We do not.
That's the only one that says we do not have sufficient.
Yeah.
All right, guys, let's see how we did. I'm doing it. Oh, no. We missed 3. Question 16. Oh, no. Okay, we missed 16. We missed 15. Those are the ones we were confused on, too. So 15 and 16.
Oh, and 10. Shoot.
Well, 10 we can easily figure out.
Yeah.
Maximum variance. Oh, wait, no. 10. The test for equal variances.
So then, was it 15? Like you said, Elise said, wouldn't it be the fourth one? For number 15, do you remember?
Yeah, that was the one that that's what Elise thought, and I think she was probably right.
Yeah, me
and
too.
Then
number 10 would have been true. Wait, was it? Number 10 would have been true, but why?
I'm confused on 16. I don't know.
I think 16.
Wouldn't it be the last one? Wouldn't it be number 4? Because they haven't been met, and we know that the variances aren't equal. So wouldn't it be number 4? Because we cannot assume that the variances are equal. Because we know it's not number 1, and number 3 says that the variances are equal.
I think it is number 1, though.
Oh, it is? That they have been met?
On number 6.
Didn't we put that for the other one? Because it's talking specifically about the QQ plots.
Oh.
We also assume that the variances are normal.
Let's see, where's that other one that we did like that?
I know that we missed. That was number 10, right? That we missed as well. Oh, wait.
Number 14.
The variances were normal.
Ah. Okay, I hear you.
So how did we know that the variances were normal again, are equal?
Because the QQ plots
normally distributed.
Yeah, all of them are normally distributed.
So it would be then the first one on number 16. Right?
Yeah. That's what I would put.
Sweet. Awesome. Well, other than just fixing those ones, I think we did a pretty good job, you guys.
This is the first one. I think so too. Not yet. I'm going to go redo it.
Me too.
Perfect. Me too.
Oh, I'm so sad that Megan didn't be on here with us.
I
I don't
know.
know.
No, did she say her whole day was busy?
Yeah, she has her kids'
Yeah, I'm getting ready.
Halloween thing. Halloween parties.
Oh yeah, she has to go to her kids' class. Okay, well, bummer. Oh well. Okay, well, thanks, guys. It's great.
Yeah,
Thank you.
Thank you.
You guys are
Link
awesome.
today, Joe.
What's that?
I said you guys are
Thanks for
awesome.
doing the link today.
Oh, you're welcome.
Oh, yes.
Okay, I'm gonna stop the broadcast.